In this video, I wanted to give a demonstration of how to set up a motor start-stop program in a PLC that's controlled not only by real hardwired switches, but also by virtual switches in the screen of an HMI. So right here you see the program for the Allen Bradley Micrologix 1000 PLC, typical start-stop with seal-in contact controlling a motor. What I'm going to do is augment this program a little bit. I'm going to add a couple more contacts to it. First, I'll add a contact here. It's going to come from a binary file, B3, element 0, bit 0. And this right here I'm going to call my HMI start. It's essentially my virtual push button that's going to go in parallel with my hardwired push button bit, and that's going to turn the motor on. I also want to add a normally closed contact right here. This is going to be also a binary file, B3, element 0, bit 1. I'm going to call this HMI stop. These are binary bit files instead of being input bits, because it's not coming from a hardwired input, it's coming from the HMI. We just need a bit space in the PLC's memory to receive those discrete signals to start and stop. Quick syntax check, and I'm going to download this to my PLC. So I've got RS links running, and I've got the cable connected, so I'm able to download the program to the PLC, and we'll see it run here very shortly. Now, the run demonstration I'm about to show you right here is not using the HMI contacts, but just the hardwired start and stop. Here we go with the start, and there we go, the motor's running. I'm going to push my stop switch, my hardwired stop switch. There we go, the motor's stopped. So we've proven that the program works to start and stop the motor through hardwired switches. So what I'm going to do here is go offline and close down RS Logix MicroStarter Lite. I'm going to immediately go to the Seymour microprogramming software, and I'm going to set this up for communicating to my PLC. So building a new project with this type of HMI, I'm going to be communicating to a Allen Bradley Micrologix PLC using DF1 protocol. I'm going to be doing so at 9600 baud. I happen to know my PLC is set up like that. I click OK, I'm ready to start my new project. Also want to make sure I swap the cable around here. Take out the PLC programming cable and connect the cable between the PLC and the HMI. I'm going to need that a little bit later. So we pan back to this, and as usual, my first step in setting up the HMI program is to configure the database for the tag names that I need. So into the tag name database for device number 1, I'm going to add a few tags. My first one is going to be called start. This is going to be the virtual push button switch on the front of the HMI. This is going to go into a memory address B, file number 3, element 0, bit 0, corresponding to the bit that I put in the PLC programming for the HMI start button. This next one is going to be stop. It's also a discrete memory type, binary type file, file number 3, element 0, bit number 1. Again, corresponding to the contacts I put into the program. So we've got some tag names here, start and stop. They're both discrete, going to those addresses. I'm also going to add another tag name here showing me when my motor is running. And I'll call this motor run. This is also going to be a discrete tag, and it's going to come from output memory type. Output, there we go, file 0, element 0, bit number 0, which happens to be my motor. I'm going to add that in there, close it out, and there's my completed tag name database. So now it's time to start putting objects on the screen. I'm going to put a switch up here first. I'll go over here, pick a suitable switch, move this over here. This is going to be my start switch. I'm going to link it to the tag name called start. I want it to be a momentary switch, like that. And the label on it, I'm going to give it a name called start. There we go. And I'm going to click OK. Oh, sorry, before I do that, I need to assign it to a function key, because my HMI does not happen to be a touch screen. So I need to link it to some of the function keys so I can make this thing actually work. So there we go. I click OK, and there's my start switch. I'll expand it a bit so you can read the word start. Then I'm going to do this with another switch. Same sort of treatment. This is going to be my stop switch, so I link it to that tag name. Once again, momentary contact. I want the label to say stop. And this is going to be linked to function key number F2. That goes over there. And I'm going to widen that just a little bit and make it look more like the other one. So start and stop. We've got two switches ready to go. We're not quite done. We need an indicator. Not an indicator button, actually, but an indicator light. Something to tell me when the motor is actually running. So what I want to do is pull over something like this. This is going to link to my tag name called motor run. And this is going to have a couple of different text for on and off modes. So this is going to say run, and this over here will say stop. There we go. No need to link it to a function key because this is strictly an indicator, not an actual push button. It's a read, not a write. I'm going to put this over here, and I'm going to stretch it out a little bit so that when it says stop, I'll have enough width to show all the letters. So start, stop, and my run indicator right there. So now I'm ready to send the project to the panel. I'll save the file. There we go. And then I want to transfer to the HMI panel. So I'll click the transfer button. And with the Automation Direct C-More Micro, I want to make sure my HMI panel is in the setup menu right here so it can actually load the project. You get there by holding down the F1, F5 function keys for a few seconds. If you don't do that, you're in the normal screen, it won't transfer the project. Learned that the hard way after trying several times. There we go. Project transfer is complete. So now I should be able to watch this system work. So panning over here where I can see my physical switches and looking at my HMI, here we go. We see the start and stop buttons. We also see the stop indicator. If I reach over here and momentarily touch the start switch, I see the motor's now in the run state. If I momentarily touch the stop switch, it's now in the stop state. So that furthest right indicator is indeed showing us the status of the motor, or I should say the output bit in the PLC if it were connected to a motor. However, I can also come over here and hit my function keys. There's F1, I just started it by hitting F1, and here's F2, I just stopped it by hitting F2. So start and stop from the HMI, as well as start and stop from my hardwired switches. So I've got control over a motor, start, stop, latch, and control using an HMI in addition to hardwired switches.